Hi everybody, and welcome to the Software Design Simplified live stream. We may have a few other people joining us. I can just hear somebody there. Hey, it's Jake. Hi Jake, how's it going?
Hi John, not bad, you?
Yeah, good, thank you. So we're just about to start now. So this is the agenda I've got for you all. We're going to be looking at coupling today. The wonderful world of coupling, how to make your app very difficult to change or very easy to change, depending on how you want to look at it. So we're going to introduce the calculator challenge we're going to be working on, which is this thing here. It's from this lovely man called John Crickett, who is very active on LinkedIn. We'll do a bit of mobbing. I'll cover kind of what is coupling, how to spot it, how to fix it, all in 5 minutes. Yeah, I know, ambitious. And then we're going to put some of those ideas into practice with our second set of mobbing. And then I'm going to show you the solution that I came up with, because I don't think we're going to, it's quite complex, the code that we're going to be working with. So we're not going to get that far, I don't expect. And so I can just kind of skip to the end and show you what you could have won, almost like a complete solution. Any questions before we get started? Silence indicates consent. So let's go. The calculator challenge. Here it is. This week's challenge is to build your own calculator. Set up your environment. Thankfully, I've already done that for you. We're going to be using IntelliJ, and we're going to be using Java. And step one is you need to handle 4 separate expressions, and you need to handle these as input and return the correct answer. And then step 2 is to handle some more complex expressions like 1 + 1 × 5. So let me introduce you to what we have here. This is an example. I'm going to just expand the screen a little bit. A thumbs up reactions on Zoom if you can see this, thumbs down if it's a bit too small. Is that okay for you, Jake? Yeah, awesome. So, so this is the calculator. It said it's authored by me, but it's not. I've taken an open source calculator that somebody created, and they didn't do that good a job. Let's put it like that. And it's got some defects in it, and we're going to fix those defects. So we have a whole series of tests here. And the first thing you need to do before you're doing any changes of any code, of course, is write some tests and make sure the system is not going to break when you change or refactor, not change the behavior, of course, but refactor. So we've got all these fairly simple addition, subtraction, multiply. And then we get into the really interesting stuff, which for this example is not that interesting. 1 + 1 + 5, and then 1 + 1 × 5. So if I run these tests, which I do by clicking on the run tests up here, something's gone wrong. The current implementation of this calculator does not return 6. 1 + 1 × 5 is not 10, because the multiplication is done first. So the correct calculator should do 1 × 5 first, and then add 1, creating 6. What this has done is done 1 + 1, and it's times it by 5, giving us 10. So we've got a problem, we've got a defect there. And then, bizarrely, this actually gives 6, believe it or not. So we've got a couple of defects there, but it's this one that I would like to focus on. And so we'll know when we're done, when this particular test passes, and we can right-click and just run this test. And so that we can get this passing, and then we'll make sure the whole calculator works by running all the tests. So without further ado, let me kind of walk you through this code a little bit. I just want to kind of introduce the main interesting areas. And so I've actually made a little diagram here. And this is broadly speaking the structure of it. So we've got our GUI here. Oh, hey Daniel, how's it going? Can you hear me, Daniel? Okay, I'm just going to bash on and assume that you can hear me. So this is the calculator that we're working with. It's kind of a high-level diagram, Daniel, and it's got all of these different elements to it. So this is the GUI. The GUI has some buttons, and it has this text field, which is helpfully called text, which is an interesting name, isn't it? And then we have some initialized logic. We have an operation method, and we have an action performed method. And it took me a long time to understand this. So I'm hoping to help you out here by explaining it. The buttons, whenever one button is pressed, this action performed method is called, and the argument that it's passed defines which button has been pressed. And then there's a Mahusive switch statement, basically, that decides which button to press, and therefore it defines which action to take. And so therefore this operation is called. There's a sneaky bit of callback to the UI here, which we'll talk about in a minute. And this also calls back to the UI, and it sets the output. So that's the overall structure. Questions, comments, thoughts before I dig into the code? So we've got these four methods. Operation is the one I talked about here. Here's action performed. And value text, I should say, is a method that I had to add so that we could even write any tests at all. This is not great because it's breaking encapsulation and it's reading the internals of the calculator, but it was the least of all evils because at least we could then actually test it because this is a GUI app. I should probably, just by way of introduction, actually run the thing. This is what it looks like. 1 plus 1 equals 2. Hey, 1 plus 1 times 5 equals incorrect. So we're going to do some mobbing now, and we're going to delve into this code. And the way we're going to do it is you're each going to take remote control of my screen for a few minutes, 5 minutes, maybe even shorter than that, and we'll just attempt to fix this defect. So Jake, if we can start with you, please. I'm going to go to IntelliJ. I'm going to expand operations so that you can see the result, the innards of it. And I am going to give you remote control. So when you're ready, just click the screen.
Okay, I'm in. Okay. Feel free to shout things out. So
what we're going to do here, Kwaja and Daniel and me, but I will try and not get too involved. We're going to tell Jake exactly what to do. So we've got this operation and it's being called here. And we're also doing an addition here. It's also being called here, which is subtraction. But we're just interested in the addition and the multiplication. So I'm going to set a timer going for a few minutes. What do we think the first step is? Anyone? Jake, what do you think the first step is?
I'm not too sure, to be honest. I'm reading this code and thinking, well, there's a lot of code for what it actually does, or what actually needs to do.
Totally. When I look at this code, my first reaction is exactly yours, which is, what the heck is all of this? And that's our first clue, right? That something is up. And it's our first clue that this is not going to be as easy as it should be.
Write a test.
We've actually got the tests.
Okay.
So this one here, if we run this, it's failing. So how are we going to get that passing? We need to get that passing. And all we've got to go on is this operation thing. Like, I don't know about you, but personally, I wouldn't have a clue where to start with this. This is difficult deliberately because we have this operation here and it's doing it step by step. So it does 1 + 1, and then it returns that value, and then it times it by 5 and it returns that value. So what we'd actually need to do is reorder the operators, right? We'd need to say 1 + 1, don't do that immediately, store it in a buffer somewhere, and then times that by 5 and store that in a buffer somewhere. And then basically, because 1 × 5 comes first, we'd have to select that in the buffer.
Feel free to shut things up.
So, to save us some awkward silences, what we could do is start building up a list of operations and numbers. So we could do something like every single time this is called, we could say something like operations dot add data. And this could be an array. So we put it here. And then we could also say operation numbers dot add. And then, you know, whatever this is actually the value from the UI. So we could say current. There's a problem here as well, because this current is actually not even passed in. Sorry, it is passed in here. So this current here might be here. But then, like, how would we even sum those numbers together? So the problem we've got here is, kind of cut to the chase a little bit, we've got coupling. We've got a lot of coupling. We've got coupling between here and here. And we've got coupling here between here and the UI. So it's this big nested ball of spaghetti nonsense. And it's very difficult right now to tease it apart and get any kind of traction on what we're trying to do. Kwaja, what questions do you have about that?
Yeah, actually, it does not make a lot of sense right now. But yes, we can go with buffers, maintaining buffers for the starters. And
what doesn't make sense? Are you saying the code, or are you saying kind of the calculation?
No, actually, the fact that it's so much coupled, so you cannot, backtrack to what called what and what happened and what led to something. So yeah, it's totally coupled.
And what
seeing this sort of code like makes me want to rewrite it altogether.
Yeah, totally. I think everybody's had that feeling as a developer, right? You've got this massive nested, complected mess, and you just want to say, just rewrite the whole thing. But of course, in the real system, this completely complicated mess is going to be something that does some serious business logic. It may well deal with paying customers. And so the question is, how do you approach that mess and not break anything? And this is where I'm going to talk a little bit about what coupling is, how to spot it, and how to fix it. So, what is coupling? Imagine this rather ridiculous image here. There's a train station at London, and a train is waiting to go to Paris. And normally, all three carriages would be coupled together by couplings. And so when the train moves, when the locomotive moves, all carriages move together and they all go to Paris and everybody's happy. Fine. What happens when coupling is too loose, which is something people don't talk very much about. It's far more common to have tight coupling. When coupling is too loose, this carriage and this carriage is not going to be coupled, and neither is this one. What happens? Well, this carriage is pulled all the way to Paris, and then theoretically, I suppose you'd have to take the locomotive back and pull each one of these to Paris, and it's extremely laborious and time intensive. This is kind of analogous to in code. Have you ever, thumbs up if you've ever had that feeling of, I have to change this one thing over here. Now I have to change, oh no, now I have to change this other thing. Oh, and this other thing, and this other thing, and this other thing. Have you ever had that, Kwaja? Can you think of a recent time you've had that at work? And if so, what was the example? Or Jake?
We build in microservices, so when you change one thing, it's going to go downstream and affect the service that calls, and then the service that calls that. We've got something at the moment where if we change like a smart contract, then we have to change 3, nearly 4 other services upstream.
Right, I'm glad you brought that into the discussion, because we're next going to talk about coupling that's too tight. What you just described there is the opposite problem. So too loose is you have to change lots of things all at the same time, and you have to push all the carriages individually one by one. Too tight is when you have all of these 3 carriages and they're all coupled together, and that's cool. But this random guy here, who is extremely fashionable and very po-faced, gets his coat caught in one of the carriages, gets caught in the door. Now, guess what? He's going to Paris as well. So he gets dragged along by the train, and he's screaming, "Let me out! Let me out! Help! Help! Help!" He doesn't want to go to Paris, but he's tied up with the rest of the train. So he's going to Paris. And now you need to somehow, process of decoupling is detaching him from the train. The process of decoupling is making sure that the train and all its carriages, and only that, go to Paris. And what that looks like in code is you have a whole bunch of code that you need to change. If changing one thing has this ripple effect, as Jake was describing there, that is tightly coupled. You don't want to change one thing over here and have 6 unrelated things completely break. If you have to make one change over here then 6 little changes in very similar bits of the code all the way throughout. That is too loosely coupled, otherwise known as duplication. You need to bring that together and extract the right interface. What questions do you have about that? Kwaja, does that make sense? Give me something here. Everyone's very quiet.
Yeah, it does. It does make a lot of sense.
Yeah,
and maybe tell me if I'm right. Talking about the loosely coupled methods or contracts being loosely coupled. So maybe we have private methods that we are using in one file, and then we have another private. In order to decouple it, we have written or extract some code out to private methods. So maybe we have those methods in separate files, which leads to code duplication. So does that mean, because I'm kind of sort of confused about the methods or the code being loosely coupled. So does that always lead to duplication?
Okay. I think I sort of understand the question. Are you saying that if you've got private methods, say we've got 2 classes, I can just draw it out here actually. We've got 2 classes, class number 1 and class number 2. And class 2. You're saying each one has private methods, right?
Yeah.
So you've got private. Can you think of an example? So, well, let's just say do something, and this is private. You've got do something else. Are you saying these 2 have duplication in, or are you saying that these 2 are completely different code samples, different?
No, these are exactly similar things, but we cannot, use one method in the other class. Maybe it's in another microservice or something of that sort.
Got it. Okay. So you'd have some duplication in here, and they'd be kind of similar. And your question is, what are these coupled together, or like what do we do about this? What's your question?
Look, like have we decoupled maybe in microservices too much that we have to move forward with duplicating the code? We end up duplicating it.
Yeah. So sometimes duplication is a really good thing. There's lots of different trade-offs to duplication. You can have things that are too devoid of duplication, too dry, and then things are really brittle. So you might have a microservice here and a microservice here. And I've watched a few talks where some people are saying, actually, sometimes microservices that are too dry are not a good idea. Because if you take this, and you say, oh, they're both duplication, let's remove the duplication. Now let's have a shared thing up here. You've got kind of 2 options.
Yeah, we end up placing in some sort of common repository or something.
Right, exactly, in some kind of a common repository. So this is some kind of a shared service. It can be either a shared service, and you call out to that shared service from both of these methods. And the methods are kind of essentially empty. They just delegate to this thing here. And then the other one delegates to this. And that's cool. But now what happens if you change this? You change this, you've coupled both of these microservices to this service. And that means that potentially they're going to be relying on something. And it gets even worse, of course, if you have 10, 15, 20 of these things. Potentially, if you change something in here, you're going to cause downstream changes to 2 things both at the same time, which is great if that's what you want. But sometimes these 2 services are on different life cycles. So then you're talking about versioning. And now you have a versioned microservice And this depends on version 1. And this depends on version 2. And then now you need to keep 2 versions of it active. Now you've got a whole other set of problems because, of course, if you create a new version, you're creating more duplication, right? That's essentially you're having to operate 2 things at the same time. So you kind of got duplication in the amount of work that you're doing. So the other option, of course, is to use a library to do all of this instead of a shared service. And I watched a talk a few years back that gives you all the different trade-offs for all these different things, when to use a library, when to use a service, and when to duplicate it and just live with the duplication. Because sometimes if it's not masses of code, sometimes actually the duplication is better. But it's all to do with how expensive this coupling is, how tightly are they coupled, is the kind of coupling that you're going to create worse than the problem that you're trying to solve. So like loose coupling, perfectly loose coupling is not always the best idea. Any follow-up questions about that? Anything anyone wants to ask? Does that answer your question, Kwaja?
What would you rather have? John, would you rather have tightly coupled or would you rather have loosely coupled?
Well, that's the thing, isn't it?
What would you rather avoid? Sorry.
Well, the question is, what are you trading off for what? Obviously, all things being equal, if you have 2 completely different concerns, and we're going to come on to concerns in a minute, if you have 2 completely different concerns, then they should be loosely coupled. But if you loosely couple them, you end up with this problem where they're both sharing the same piece of code. And so therefore, that can cause unintended consequences. It just depends what your problem is. And it depends what you're trying to achieve. So there is not a one-size-fits-all, but the question is, by introducing this extra abstraction and coupling these 2 things to this service or library, what other problems are you going to introduce? Sometimes you introduce it and you loosely couple them and you realize, oh man, this creates more problems than it actually solves. But you can only do that by working with the code and extracting them. And yeah, so this would be the thing, the general feeling. If you change one thing and a million other things break, you're probably too tightly coupled. If you change one thing and now you need to change 100 other things, you're probably too loosely coupled and there's some duplication that you need to clear up. It's not really a definitive answer, I know, but when we come on to this, you'll see some of the trade-offs. So we're going to have a little bit of mobbing. It's just going to be you and me, Jake. Kwaja and Daniel have left. So yeah, this is what we've got. So we're going to actually talk a little bit about, we've talked about what is coupling. We've talked a bit about how to spot it. So how do we fix it? So this is a kind of a process to spotting coupling and changing it. So we're going to attempt to change. Do we have significant pain with the change? And that's kind of the critical answer to your question, Jake. Which would you rather have, loosely coupled or tightly coupled? Depends how much pain it's causing you. If you can change one thing, it doesn't cause a massive ripple effect, and you change one thing and only one thing, that's kind of the perfect scenario, right? You just change it and it's beautifully encapsulated. No, all good. If you do experience some kind of pain, the next question is, what kind of pain are you experiencing? Are you not clear on what to change like we were before? We just looked at the code and there was just a bunch of stuff in the method. And you're like, oh man, this is so tangled, I don't even know where to start. Or is it a case of we've just changed that one thing to try and get to a solution and now a million other things break? Or is it we now have to change lots of scattered things. So we're kind of in this third camp. We're not really clear on what to change. So the first step is list out the concerns that we have. And this is a bit of a tricky thing to do. And I've had a career of practicing this kind of listing out concerns, and it gets easier over time. But if we were to look at this code here, all the different parts of this code, I mean, we can't skim through all of it, but line by line, if we go through, this is kind of what I would call a calculation concern. That makes sense, Jake?
Yeah.
It's responsible for calculating numbers. What is this? This text is it's actually linked to the output of the calculator. So this is setting the output of the calculator.
Mm.
Is that a calculation concern, or is it something else?
It's another function, isn't it?
Yeah, right. It's another function of this method. So this function here is actually changing the GUI. So now we've got calculation, GUI, and then some stuff here, it's not quite clear what's going on. So calculation, GUI. And so this here is extracting the number from the GUI. So it's kind of GUI UI concern. And then we call the calculation method if these two things are true, which is not clear what's going on there. And then here, GUI or calculation? What do you think?
GUI?
I'd say this is calculation.
Mm-hmm.
Why is it calculation?
Well, we're gonna need this number to calculate the next stage, right?
Right, but it's not actually doing any of the calculation. It's extracting
Fair.
it from the GUI. So you could kind of paint it both ways, but I would say it's extracting it from the calculator, so it's reading it from the GUI. You could argue there's like a third concern here, which is kind of inter-process communication, or like extracting stuff from the UI. This we're not sure about. These are kind of temporary variables. These are adjusting internal state, which is always a little bit of a red flag to me when it's not really doing anything. It's just shunting some numbers around internally. And then this, what do you think, Jake? Calculation or GUI?
Calculation.
Yeah, calculation or GUI?
GUI.
GUI. Calculation or GUI, kind of neither. So we've got this weird interleaved calling operation that's doing some calculation, GUI, weird, back into this. Sort of GUI, sort of communicating between the GUI and the calculation, but strange juggling stuff around, calculation, and then GUI. So this is coupling. This is a great example of coupling, because this method here is very tightly coupled to both the GUI and the calculation. It's all kind of mixed up. It's like this spaghetti. It's a soup, all these different things. So what's the next step? So we've got our concerns, which are UI, GUI, and calculation. Which is the concern that we want to change, Jake? Do we want to change the GUI, or do we want to change the calculation? What's a defect?
I think we should probably extract out the GUI from the calculation methods.
Totally, because it's the calculation bit that we want to change. We don't want to change the GUI. And more importantly, we don't want to fiddle around with the calculation and all the numbers go wrong, or all the buttons fly everywhere. So the next thing we're going to do is exactly what you've just said. We're going to split the code into two. We're going to create what Michael Feathers calls a seam, a split in the code. And creating the right kind of seam is a real art form, because you create the wrong kind of seam, you get the wrong abstraction. And when you get the wrong abstraction, it's even worse than it was before, potentially. You can actually end up coupling things even tighter than they were before if you choose the wrong seam or the wrong abstraction. And then we're going to extract gradually. We're going to kind of cleave the two apart gradually. We're going to end up with all the calculation stuff in the calculation bit and all the GUI stuff in the GUI bit. And then once we've got this with some kind of clean connection between the two or interface, then we can make our change in the concern that we care about, the calculation, and we're not going to affect the GUI. What questions do you have about that, Jake?
So if we're not breaking tests, how are we going about this? I've never heard the term seam before.
Yeah, it's a great question. I love it. And that's what we're going to pair on a little bit. So we've got 20 minutes left of the stream. I really regret making this an hour. We've got 20 minutes left. So I do have a solution pre-prepared that I really want to show you. But I would like you to just take you through kind of the very first step in introducing this seam. So this is a really tricky one because you've got this this horrible method that is reducing the purity. So the first step I would take is look for the simplest way of cleaning up one of those responsibilities. So if we look at this method here, we've got a whole load of stuff all interleaved. Whereas in this method here, the only impurity, if you like, is this one method here that's setting the GUI. So we want to look for the smallest step that's going to start cleaving these two things apart. So I think this is a pretty good start. So we're going to make sure we're running all the tests. And we're going to refactor on red. It's a technique I was taught many years ago. So we don't want to change the behavior. You want the behavior still to be broken and broken in exactly the same way. Make sense, Jake?
Yeah.
Okay, so we've got all of this shunting around. It's also made more difficult by the fact that this result and number are state in the object. So we're actually monkeying around with the internal state, and therefore that can affect something outside. So what I want this to return, I don't just want it to return a void. So I want to get the results of that calculation, because then we can set the calculation in the GUI, the results of that calculation. So we look where operation is called, which is here. We're just going to do the addition for now. And we're going to take this and we're going to duplicate it down here. We're going to say this is going to be a double. Deliberately not tying it into any operator, current, text, because they're all coupled to the state. They're all coupled to all sorts of internal state and instance variables. Don't want to do that. And now we're going to set the result of whatever the operation is. Now it's warning me because it's saying this operation is a void. What on earth are you talking about? I can't, it's not got a return value. So we're going to make that into a double. And what do you think we would output from here, Jake? What variable are we going to return?
Result.
Exactly, result. A bit weird because result is an internal variable, but if it works, personally, I don't care. And then we're going to delete this. And this is going to be the bit where the tests either shout at us, and they do. Expected 1, actual 2.
Since you're using IntelliJ, I believe if you click the 3 buttons, at the bottom, at the top left corner of your bottom toolbar of the test runner.
Bottom.
I can annotate. Can I annotate?
Yeah, you should be able to. You should be able to take control of the screen, actually, if you want.
Yeah. No, this one. This one has an auto test toggle.
Oh, nice.
So now when you run the tests, you don't have to run them manually.
Very nice. So let's stop the test, and then
you just change the code, and when you change the code, it'll run the test.
Very cool. Okay, so we're going to put that. We're going to undo that. That mess things up somehow. I think I know how actually. Did it run the tests? Doesn't look like it did. Right, so we're back to failure, but the right kind of failure. My hypothesis is it's because we didn't change all of these.
Mm-hmm.
So I'll redo what I did.
Can I make a suggestion?
Please.
For extracting, since we're changing the signature of the method, and the void function operation is being called several times, I would be much more comfortable if you for just temporarily maintained the void function that we can call, then it's the void function that has the extraction, so that we can be even dirtier, but we don't have to do everything we wanted to do.
Nice. I'm trying to take 2 big steps.
Yeah.
So what we would do, if I'm understanding you, Dennis, we would extract this bit inside here into a new method.
I think everything, just everything.
Okay.
Yeah, just everything into a new method.
Okay. What are we going to call this?
Well, we're removing the print. Jake, what would you call this if we remove the print? So now it does calculate, print, and something else. But now we're removing the print. So what would you call it after we removed it? What would you call it when it only calculates and does that unknown thing at the end?
What do you think, Jake?
We're just looking for a name.
Yeah.
The hardest part in software.
Calculate and print.
We're not printing, so we just calculate. The print is what we're removing, right? Without printing. Nice, I like that.
I'm just going to say calculate without printing.
Nice.
And so we're going to remove that, right? Oops.
Yeah, now this one can be the void function. The double, or one that we're trying to double.
Yeah. Calculate.
I like that too. Like when you hit escape during the refactor and then the rename bugs out. Not perfect.
So calculate without printing. We want to remove that and put it in here, right?
Yeah.
And we want to do double result equals
What we did earlier wasn't wrong. It's just that I personally felt uncomfortable because we changed the signature of a method that we used in, I think, 5 different places.
Yeah.
And I don't know enough about the code base to be comfortable with such a change.
So we're going to return result here. If we've done that correctly, everything should still pass.
Why is your test runner not running?
Great. I mean, it passes, obviously, it fails in the right way.
Yeah.
So this tiny little move that Dennis has suggested is awesome because now we've separated out, we've done what we said we were going to do. Right? We've separated out the calculate into the calculate without printing. And so now this thing can start to move into, let's just complete the rename with calculate with printing.
Nice. This is composition. I like because it's clear in the naming that it has something to do with composition.
And so now
one does, one doesn't.
The natural thing would be to call this calculate, but I will resist the urge to do that. Let's make sure that naming didn't break anything. Right, Jake. What are your thoughts around what we've just done? Can you explain to me what we've just done there?
We've substituted the operator method we've basically made our own function.
Yeah.
And we're going to pass that in instead of changing it everywhere.
Yeah, we've made our own method and now it's calling calculate with printing all over the place. Number one, the name is actually clearer now. So we know that it's got 2 different concerns together. It's not a great name, but at least it's obvious. Before it just said operation, which is like, what's that doing? We've actually explicitly declared now, oh, this is dealing with 2 things. So we're already in a better place. And we're in an even better place because we now have, ta-da, the golden chalice, a method that does one thing. Apart from this stuff down here, which I'm sure we'll come on to. Okay, so the next thing to do would be to push this out into a class. And I would say that's because what we want to do is swap out the calculation for the correct calculation. So this is being called all of the time in our method, and it keeps doing it incorrectly. So we need to swap out that calculation bit for a correct calculation. And that means if we extract that into a class now, which I'm not going to do because we've only got 10 minutes left and I want to reserve some time for to show you the solution. But if we push that into a class, we could then wrap all of this stuff up in that class. That gives us our scene. In fact, this is the beginnings of the scene. That gives us our scene. We've now split it into 2 things. We can now change the calculation completely independently of the GUI. And that means we can fix our defect. Because the defect, it turns out, is because we're not doing this in the correct order. It needs to be done this bit first and then this bit. And so this is where reverse Polish notation comes in and all of this interesting hunting yard algorithm. This is an algorithmic change. I won't go through it now because we've only got 9 minutes left. But I am going to quickly check out one I prepared earlier. Okay. So this is kind of the same code in many ways, but I've wrapped up all the calculation stuff into this thing I've called an expression. This is the class that we were kind of starting to move towards there. So we've got various different, we've got an interface to this class, and there's all sorts of things in it, but the main things are a method called type operand, which means that I'm typing a number, and then I'm typing the operand, which is a plus and a minus and multiply, and then a type equals method, and then finally we've got a method called evaluate, which evaluates the expression and gives back the result. If I scroll down the action perform method, you can see it's changed quite a bit, quite a lot simpler. What questions do you have about how this is working, Jake?
None really. I can see. See, it just gets this function button method you've built, or is that pre-built?
That determines which button has been pressed. If I had more time, of course, we'd refactor this into a proper name and make sure this says add is pressed. That's what that Boolean should be called, is add pressed. If add is pressed, then again, this shouldn't really be here, but if add is pressed, then type in, give the expression, whatever we've got currently in the text buffer, and the operand plus. If minus is pressed, same thing with minus, same thing with times, same thing with divide. And then if the equals is pressed, we call this type equals with whatever is in the buffer. And then we call set text, which is, remember, GUI concern. So this is just dealing with the GUI. It calls evaluate on the expression, which gives the expression time to rearrange all its components in the right order and get the calculation right. So what we were doing before was immediate evaluation. The moment we typed some characters, that operation method was kicking in and trying to do stuff. And so it was just keeping this running total as we went along. That's fine if you're adding an infinite number of numbers or minusing, whatever. But the moment you start doing addition, subtraction, brackets, we all know it's not the same order, right? So we've got this immediate evaluation expression. The other thing is, I don't actually have to explain really too much to you what's going on in this method, in this class rather, because we don't have to care about it. We've separated out the two concerns. We've reduced the coupling. How do you think, Jake, we will get from here to the correct expression? Like, what are some strategies we could use to fix the defect?
What is the current defect at the moment?
The current defect is this thing here. 1 + 1 × 5 is 6. It comes back with 10 instead of 6. And you can see, despite me extracting all the method out and doing all this fancy magic, we've still got this one failure here. It's still doing the wrong thing.
Right.
But at least now we've got all the wrong thing in one place.
Right. We need some order of operations somewhere.
Exactly. We need to change this class. So instead of evaluating things immediately, it keeps a running score. It doesn't keep a running score, sorry. It keeps a record of all the operations. And then when you hit evaluate, bam, that's when it kicks into gear and it defines which comes first, which comes second, all the rest of it. And as if by magic, here's one I created earlier. So before I go into that, I want to just talk a little bit about the interface. This interface has a couple of things it shouldn't have, so it's not quite as clean as I would like. But the main things I want to point out are the type operand and the evaluate and the type equals. I've also added type opening and closing bracket because I thought it would be a nice, interesting exercise to do. But this is the interface between this immediate evaluation, which is wrong, and the GUI part. This is what we would call a seam. This is an interface. It's splitting it. Now that we evaluate, now that we've created an interface, the really cool thing is we can implement that interface with different behavior. What do you think I mean by that, Jake?
You can have two different classes using the same interface.
Exactly.
They can do slightly different things. So maybe evaluate could do something different in reverse Polish notation than reverse Polish notation expression.
Exactly. Just ignore this class. This class shouldn't exist. I also think reverse Polish notation expression is a terrible name for a class because it's exposing exactly how it works. This should be called lazy expression, and this should be called immediate expression or something like that. Lazy evaluation and immediate evaluation, that's the difference between the two. Who cares how it does it? So here we go. Here's our new class. We've got our type. Sorry, that's not a public interface thing. Where are we? We've got our type operand. We've got our type opening and closing bracket. We've got our evaluate. And we've got type equals. And the cool thing here is because we've created this seam, we can now test this independently. We can test this without the GUI at all and make sure it does the right thing. And once we've done that, we can swap this out for reverse Polish notation expression, run the tests, and they all pass. This is incredibly powerful, and it's
is the seam always an interface?
Doesn't have to be. No, doesn't have to be at all. The seam is just a way of splitting them. Seams can be pure methods. They don't even need to be classes.
Right.
There's loads of ways of introducing seams.
What we did earlier with the intermediate step with the extraction, that was also a seam.
Yeah.
Sure.
It allowed us to make the step more easily. And what a seam allows, I mean, at least according to Michael Feathers, is that what the seam allows us to do is to go back to the previous behavior. That's also very important because then that opens the gates to continuous deployment, continuous delivery, and feature branch. Right? So the seam always has to be backwards compatible. It has to allow us to not change anything.
Totally, and that's why you develop seams. I mean, this is a massive step. I've just shown you. Here's one I prepared earlier. But what we do in real life is we very, very, very slowly evolve that seam, and we push a little bit more in, and then we find out, oh no, we've actually accidentally put some GUI stuff into there. No, take that back out. Push something else into the seam. Oh, that interface is janky. Now we have to have 3 different parameters. One of those parameters is stuff to do with the GUI as well. No, take that back out. And it took me quite a few hours of experimenting with different things, and then I hit on this kind of type operand and type equals interface. And that seemed to work out okay. It still needs a little bit of tweaking and a bit of finessing. So we're on time. I want to respect everybody's time. Thanks everybody who's tuned in. And if you'd like more, then come along to this stream next week. And I'll be hosting these every week for the foreseeable future. So thanks for coming along, Dennis. Thanks to Jake. Thanks to all the earlier attendees. They obviously had to go off and do something. Otherwise, this wasn't very good, maybe. Yeah, so thanks everybody. And I'll see you next time.
Thanks, John.
Okay, thanks. Bye.
Thanks, Sam.
Thank you. Bye.